If you are a beginner on web development or web security like me, one of the first concepts that you should learn is the HTTP protocol. So, hi, my name is Hisham, and in this video we're gonna talk about the HTTP protocol, how it's work, response, request, cookies, and more. Stay with me and enjoy.
Audio Jungle.
So the first thing that we're going to talk about is what is HTTP protocol. So HTTP stands for Hypertext Transfer Protocol, is the way you use it to access the World Wide Web. So if you want to access the web in general, you need to use the HTTP protocol. But how it's work actually? So HTTP use a message-based model. That's mean you as a client, you send a request message to the server and the server return a response message. So for example, if I go to my browser and I type twitter.com, so the request that I made is getting twitter.com page. And the server gonna take my request, process it, and return to me a response. Now let's go more deep in what is an HTTP request and an HTTP response. So now, to be able to see the request, we're gonna use Burp Suite to set up a proxy. I'm gonna explain what is a proxy a little bit later in this video. If you have Kali Linux, Burp Suite is pre-installed on it. But if you don't, just check how to install Kali Linux in the description below. So after you open the Burp Suite tool, go to your browser, preference, network setting, a proxy, okay. Now, I have a server hosted in my local network, which is the Metasploitable server. So, the Metasploitable server has an IP address, and the IP address is 10.0.2.254. So, I'm gonna enter this IP address in my browser. But, before doing that, go to Burp Suite, go to Proxy, and switch to Intercept Off, so the proxy cannot intercept the request. As you can see, it contains numerous web applications. Maybe that's strange for you a little bit, because when you browse a web page in your browser, you type, for example, youtube.com. This is a domain name, and actually, it's an IP address, but the DNS server, which is a server that translates the domain name to an IP address. So, the DNS server take the youtube.com domain and search for his IP and connect you to youtube.com. And the reason of doing all of this is because people cannot remember IP addresses, but they can remember domains like YouTube, Google, and so on. I think you get the idea. So now I am browsing the DVWA page. So as you can see, this is the login page. The username is admin and the password is password. Now let's go to Burp Suite and go to Proxy, switch to Intercept On. Now let's go back to the DVWA page. As you can see, we are in the home page. Let's click on About. As you can see, Burp Suite intercepts the request that was made by the client, which is me. So this is the request, and it consists of one or more headers. So the first line is a header, and the second line is another header, and so on. So the first line of every HTTP method consists of 3 items separated by a space. The first item is the HTTP method, and in our case we have the get method, whose function is to get and retrieve a resource from the web server. For example, in our case we want to get the about page. The second item is the requested URL. It's the name of the resource being requested. In our case, it's the about page. Notice that the second item is not the whole URL, just the resource that we want. Now the third item is the HTTP version being used. In our case, it's 1.1. Now let's talk about the other headers. So the second header is the host that specify the host name that appeared in the full URL, and in our case is 10.0.2.254. If you type, for example, youtube.com/channel, the host gonna be youtube.com. Now, the user agent header is used to provide information about the browser or other client software that generated the request. Now, the accept header tell the server what kind of content the client is willing to accept, such as text, HTML, XML, images, and so on. It's depending on what the client accepts. And the accept encoding header tell the server what kind of encoding the client is willing to accept. And the refer header is used to indicate the URL from which the request originated. So in our case, we made the request from the home page. So the home page is the reference of the request. Now, the connection header is used to tell the server whether it should close the TCP connection after the HTTP transmission has completed or keep it open for further messages. And in our case, the request that we made tell the server to close the connection after the HTTP transmission has completed, because the only thing that we want for now is the about page, nothing else. Now let's talk about cookie. So the cookie header is used to submit additional parameters that the server has issue with to the client. And don't worry, I'm gonna talk about cookie in more detail in this video. Now the upgrade insecure request header used to tell the browser to make requests using HTTPS rather than HTTP, because here we are using HTTP, which is an insecure protocol, because the data are transmitted in plain text. Now let's go to the HTTP response. So now, as we already said, when you browse the internet, you type a domain name, for example, utip.com, so you are sending a request to the server, and the server will send to you a response. But in Burp Suite, we only intercept the request. We are not able to intercept the response. So we need to configure Burp Suite so we can intercept response also. Now let's go to Burp Suite, go to Option, Intercept Response. Alright. Now let's send the same request that we sent before. We want the about page. As you can see, this is the request that we explained before. Let's forward it. And there we go. The server sent a response to us. And we need to understand what is this. So the first line of every HTTP response consists of 3 items separated by a space. The first item is the HTTP version being used, in our case 1.1. And the second item is a code indicating the result of the request. In our case, it's 200, and that means that the request was successful. This called a status code, and there is a numerous status code. I'm gonna talk about them later in this video in more details. And the third item is just a description of the status code. In our case, it's OK, and that means that the request was successful. Now let's talk about the second header. So the date header indicates the date that the response was sent to the client. Now the server header provides information about the web server software being used. In our case, Apache version 2.2.8. Those informations are sensitive and we can use them to attack the server. We can search for a vulnerability in the version of the Apache server. For example, Apache 2.2.8 and exploit DB. And you're gonna get a lot of vulnerabilities. I know this is an old version of Apache, but when you was able to know about the software the server use, that's gonna help you a lot to know how the server function. Now the expowered by header is set by various server to say what kind of framework the website is running. Now the pragma header is still in the browser to not cache the response. That's mean don't save the response on the browser. Now the cache control header telling the browser to not save the response on it. And in our case, the cache control header contains some options, and those options are no cache and must revalidate. The no cache mean don't save the response on the browser, and must revalidate mean that when you need the web page, you need to make a new request. The pragma and the cache control header are the same, but the pragma used in the HTTP 1.0, the old version, because maybe there are some browsers that don't support HTTP version 1.1. So they will not understand the cache control, but they will understand the pragma header. Now, the expire header tell the browser for how long the content of the message body are valid, because the browser can use the cached copy as we already said, rather than sending new requests. Now, the content length header is the length of the message body, and the connection header, we explained it before, is telling the browser to close the connection after intercepting the response, because there is nothing else to change between us, the client and the server. And the content type indicates the type of the message body. And in our case, it's HTML and text. You need to know that many other HTTP header exist. So if you see another header, you can Google it or ask me on the comment below. I am happy to give you an answer. Now, let's talk about HTTP methods. So the most commonly method used are the get and the post method. We explained the get method before, and we said that the get method is designed to retrieve resources from the server, but the post method is designed to perform actions. Let's explain that with a practical example. So let's go to Burp Suite and switch to intercept off. Now let's go to the browser and log out from the DVWA page. So now I need to submit my credentials so I can get the DVWA page. The username is admin and the password is password. Now before hitting login, let's go to Burp Suite and switch to intercept on. And as you can see, this is a post method. And that means that we are posting our credential to the server. It's not the get method, because we are not getting data from the server, but we want to perform some actions. We want to post something to the server. And what we want actually? We want to post the username and the password. So the server will verify if those credentials are correct and after return the DVWA page if the credentials are correct. As you can see, the username and the password are in plain text because we are using HTTP rather than HTTPS. Now you need to know that in addition to the get and the post method, the HTTP protocol supports numerous other methods that have been created for specific purpose. Here are the other ones you are most likely to require knowledge of: the head, trace, option, and the put method. So head functions in the same way as the get request, except that the server should not return a message body. This method can be used to check whether a resource is present before making a get request for it. And the trace method is designed for diagnostic purpose. The server should return in the response body the exact content of the request message it received. The option method asks the server to report the HTTP methods that are available for a particular resource. The server returns a response containing an allow header that lists the available methods. The put method used to upload resources to the server using the content contained in the body of the request. The status code of the response that we explained before is 200. That means that the request is successful. So each HTTP response message must contain a status code in its first line, indicating the result of the request. And there are 5 groups of the status codes. So if the status code starts with a 1, that means that the server trying to tell you something, to inform you about something. It's informational. And when the status code starts with 2, that means that the request was successful. And when the status code starts with 3, the client is redirected to a different resource. And when a status code starts with 4, that means that the request that is made by the client contains an error of some kind. And when the status code starts with 5, that means that the server encountered an error while processing the request. Now, let's talk about HTTPS. So, as we already said, the HTTP protocol is encrypted and therefore can be intercepted by an attacker who is in the middle between your browser and the server. And HTTPS is essentially the same application layer as HTTP, but it is tunneled over the Secure Transport Mechanism, SSL, Secure Socket Layer. This protects the privacy and integrity of data passing over the network. So, a man-in-the-middle attack is hard to be applied here. But what you need to know is that the HTTP request and the HTTP response function exactly in the same way regardless of whether SSL is used or not. Now let's talk about the HTTP proxy. So, in the beginning of this video, I spoke about the proxy that we run it using Burp Suite. So, an HTTP proxy is a server that exists between your browser as a client and the destination web server. And the first thing that we did in the beginning is configuring our browser to use a proxy server. And that's mean that all the requests that are made by my browser will go to the proxy server. So the proxy server can forward those requests to the destination web server or drop them. And you should be aware of two differences in how HTTP works when a proxy server is being used. So when a browser sends an unencrypted HTTP request to a proxy server, it places the full URL into the request, including the protocol, the server hostname, and the port. So the proxy server extracts the hostname and the port and use this to direct the request to the correct destination web server. But when HTTPS is being used, the browser cannot perform the SSL handshake with the proxy server because this will break the secure tunnel and leave the communication vulnerable to interception attack. So to solve that, the proxy server needs to be the client. Needs to be you actually. So your browser open an SSL connection with the proxy server, and after that the proxy server open the SSL handshake with the destination web server. After that the request send it. Now let's talk about cookies. So as I already said, cookies are just some piece of data that can be sent from your browser to the server or the server set them for you. So to make things clear, let's create a web server to see a demo. So I'm gonna use Node.js. It is easy and you don't need to know about it, just follow me. But if you want to understand how to use it properly, check the description below, you're gonna find a great article about it. So let's get started. I'm gonna use Visual Studio Code and creating a file called index.js. Okay, const an HTTP variable equal require HTTP. So the require function here is used to importing the HTTP module, just like this. So let's create another variable called server and assign to it HTTP dot create server request response. So the only thing that this server gonna do is return hello from the server to the client that's trying to connect to it. So let's do that. So res.end and h1 hello from the server. Let's close the tag. Now the server gonna listen on the port 8000 on the localhost, and let's just type console.log listening on port 8000 to be sure that everything worked properly. Alright, let's start the server. So view, terminal, and node index.js. Hit enter. Listening on port 8000. Let's go to the browser, localhost, on port 8000. Hit enter and hello from the server. That's cool. Now let's open the developer tools, go to application and cookies. It's empty because I didn't set cookies and also the server didn't set cookies from me. Now I'm gonna set cookies from my browser. Let's go to the console and type document.cookie equal to cookie from the client and the value is 100. Now let's refresh the page and go to the application. As you can see, this is the cookie that I set using my browser. Now let's go to the network to see the request that I made. As you can see, the cookie header is here. Cookie equal to cookie from the client and the value is 100. That's cool. And that's mean that I am setting cookies to the server from my browser. Now, what if I want to set cookies from the server? Let's go back to our code. So here in the response, I'm gonna set the set cookie header. So res.setHeader, the name of the header is set cookie, cookie from the server, and the value is 200. Okay, let's run the server again now, and let's go to my browser. Refresh the page, let's go to application, cookies. As you can see, I'm gonna find two cookies. The cookie that I set using my browser and the one that was set by the server. And let's go to the response. I'm gonna find that the set cookie header contains cookie from the server and the value 200. But if I go to the HTTP request, I'm gonna find only one cookie that I was set before using my browser. Cookie from the client and value 100. Now if I refresh the page again, what do you think is gonna happen? So let's refresh it and go to localhost, go to the response, set cookie contain cookie from the server, that's cool. But if I go to the request, I'm gonna find two cookies, the cookies that I set using my browser and the one that was set by the server. So now the server remember me. And that's why when you ask someone why we use cookies, he gonna say to you, listen. When you go to facebook.com for the first time using your browser, you need to enter your credentials. But if you close your browser and you open it again and you go to facebook.com, you don't need to submit your credentials because Facebook know who you are from your cookies. And how actually the Facebook server know you is because the first time I enter my credentials, the HTTP response that I get from the Facebook server contain the set cookie header. So the server set the set cookie header for me. So the next time that I'm gonna try to go to facebook.com, the cookies that are set by the server will be in my cookie header of the HTTP request that I made. So the server gonna see those cookies and gonna see, oh, I know this guy. He didn't need to enter his credentials. Let him get his profile. So that's how it's work, and that's why you need to be careful, because if someone can get your cookies, he gonna act like you. And in the next video, I'm gonna explain how I was able to be an admin on a website using the admin cookies. So thank you for your time, and if I misunderstanding something in this video, please tell me in the comments. And if you don't understand, ask me on the comments or on my social network. And if you like the video, don't forget a like, subscribe, and see you in the next video.